Hello students, welcome to the class. Today we are going to learn about the few problems related to JEE Advanced in Physics. And previous year questions we discussed right now, and one of those questions are here. And see, two spherical stars A and B having densities rho A and rho B respectively. A and B having the same radius. See, first two spherical stars. This is one star which is A, and next another star, that is B. These two stars having the densities rho A and rho B. A and B having the same radius. See, the radius of A is, let us suppose, R, and radius of B is also R. Okay, and next masses relation is given. MB is equal to 2MA. So mass of B is twice the mass of A. Due to the interaction process, A loses some of its mass. See, due to the interaction process, because of the two stars are interact with each other, and A lost some mass, and which is gained by the B. Okay, so the entire mass lost by A deposited on B. See, this is deposited on B as thick spherical shell of B. So A, some of the part of mass lost on A. So due to the interaction process, lost some of the part. The part is not given, but the radius is mentioned here, which is radius is halved. So what does it mean? The A radius is halved, means half. So A radius is half, means actually initially the radius is R, and it will be converted as R by 2, and the rest of the mass of A is deposited on B. So how the B will be converted? See, so the B having radius A, radius R, and the part of mass of A is deposited on B like a shell. So this is the shell. So part of whatever the mass lost on A is deposited on B. This mass is converted to B. Let us suppose the total radius is small r. The radius of B is capital R. The total radius along with the shell is small r. That is what happened in the problem. Then what is the question? And the velocity VA and VB are the escape velocities on A and B. VA and VB are the escape velocities. Then what is VB by VA? VB by VA is given already, root 10 n by 15 power 3 by 3, 15 power 1 by 3. Then what is the nth place? So what is the multiplication with 10 in the numerator? We need to find. So here you see, so sum of the part of mass lost by A and which is deposited on B, and how much mass is deposited on B. First we need to calculate it. So what is the MA dash? So this is mass remaining. This is the mass remaining because some of the part is lost. So the mass remaining here is MA dash. Initially mass is MA. Star A mass is MA. Star B mass is MB. But here star A mass is turned like MA dash. So MA dash, how we calculate? We calculate mass per unit volume because the density doesn't change. So initially mass per unit volume is ma by 4 by 3 pi r cube, and the mass is converted into ma dash. The radius r is turned like r by 2, so that ma dash is equal to how much volume? 4 by 3 pi r by 2 whole cube. So ma dash is equal to ma by 8. Okay, so ma dash is equal to ma by 8. Then what is the escape velocity? We know the relation for escape velocity. Va is equal to root 2g m by r. So that is root 2g ma dash by r by 2. Because we project the body from here, then it will escape with a velocity, that is Va is equal to root 2g ma dash by r by 2, which is equal to root 2g ma dash is nothing but ma by 8 into r by 2. So root 2g ma by r is taken as v naught, then which is equal to v naught by 2. So because root 2g, let root 2g ma by r is v naught, then va is equal to v naught by 2. So we find out here the escape velocity of body on the star A, and then we need to calculate the escape velocity on B. See, here some of the part is transferred to the, some of the part of mass is transferred to the B, and it will be deposited like a spherical shell. So we need to calculate the R, because escape velocity on B, if you want to calculate, that is 2 into mass 2g m. 2g m means mass of B plus the spherical shell mass, because it having mass of A is ma by 8. So out of ma 1 by 8 part is here, then what is the remaining mass is here, 1 by 8 is here, then what is the part here, 7 by 8. So 7 by 8 portion of star A is deposited as a spherical shell on star B. Okay. So 7 by 8 ma by r. So that is escape velocity of any body on star B. So let us calculate small r. How we calculate small r? Because see, 4 by 3 pi r cube minus 4 by 3 pi r cube. See, so total radius is small r. So total volume, from the total volume, if you remove this volume, then remaining volume is the spherical shell volume. Spherical shell volume is nothing but 4 by 3 pi r cube into what is the volume of the spherical shell, which is equal to ma by 3. Sorry, this is 7 by 8, right? See, the volume, the total volume minus the central part B volume, if you remove the total from the total volume, the volume of B is removed, then we get the volume of the spherical shell. Volume of the spherical shell is 7 by 8 times of the volume of the A, right? Because 1 by 8 part is here, the remaining part is 7 by 8. So 7 by 8 of volume is equal to the volume of the spherical shell. So from this, if you calculate the R, so R cube is equal to capital R cube plus 7 by 8 R cube, which is equal to 15 by 8 R cube. So that is small r we get. Finally substitute VB is equal to root 2G into MB already given 2MA. So substitute 2MA and 2MA plus 7 by 8 MA, that is 23 by 8 MA by R. R is nothing but 15 by 8 whole power 1 by 3 into capital R, because R cube we derive here, then small r is equal to. So if you calculate the ratio between VA and VB, finally we get the relation. See, the ratio between VA and VB. VA by VB is equal to, what is VA by VB? See here, if you find the ratio, VA is V0 by 2. Here VB also, in terms of V0, if you write 2gm by R, that is V0 into root 23 by 15 power 1 by 3 by 2. So in terms of V0, we write the value of VB also. So then VA by VB, finally VB by VA, sorry, here we need to calculate the VB by VA. So VB by VA. So if you calculate VB by VA, the ratio is 23 by 15 power 1 by 3. Okay students, so there 10n, what does it mean? That is 2.3 into 10 by 15 power 1 by 3. Okay students, finally we got the answer. So 10n means this is the multiplication factor 10 and n is nothing but 2.3. So the answer is n is equal to 2.3. This is the answer. Okay students, let us go to the next one. The minimum kinetic energy needed by an alpha particle to cause the nuclear reaction N716, here N716 and He24, which is converted like H11 plus weight 19. So here alpha particle is moving towards the nitrogen, which is at rest, and finally a proton and oxygen is released. In this reaction, the energy released, which is equal to Q. First we calculate the energy released, and here the question is the masses are given, and we are going to calculate the energy. Here the laboratory frame is N. What is the energy? The minimum kinetic energy. The question is here in the first line, the minimum kinetic energy needed by an alpha particle. So the alpha particle is moving towards the nitrogen. We need to calculate the kinetic energy of the minimum kinetic energy to release such an amount of energy. We need to calculate in this question. So that how much amount of energy is released. First we calculate the how much amount of energy is released, which is nothing but mass defect. Mass defect into atomic mass unit, which is given 930. Mass defect is nothing but, what is the mass of nitrogen? 0.006, 16.006 atomic mass units, and next helium 4.003, and it will be converted into proton, which is 1.0084 minus 19.0034. This is called mass defect. So because mass of neutron plus mass of helium minus mass of hydrogen minus mass of oxygen is nothing but mass defect, which is multiplied with 930. Then energy is given in MeV. The total amount of energy lost we measured in MeV. So if you calculate the value, which is 1.86 MeV minus 1.86, that is energy lost, and energy absorbed. Energy absorbed is nothing but 1.86 MeV absorbed energy. So energy loss is negative and energy absorbed is 1.86, because the kinetic energy of alpha particle is, and finally due to the kinetic energy of alpha particle bombarded with nitrogen, and the energy lost, the maximum kinetic energy lost is converted into absorbed energy, which is 1.86. So maximum kinetic energy lost is equal to half mass of alpha particle into mass of nitrogen by mass of alpha particle plus mass of nitrogen into velocity of alpha particle square is equal to 1.86, because this is equal to kinetic energy lost is nothing but the absorbed energy 1.86 MeV. So if you substitute, mass of alpha particle is taken as m. Let us suppose the mass of alpha particle is taken as m, then mass of nitrogen is nothing but 4m. because see, this is mass of alpha particle and this is mass of nitrogen. 4 times is given in the problem. So that mass of alpha particle is m and mass of nitrogen is 4m, and finally m plus 4m, which is into v square is equal to 1.86. So finally the half m v square, that is the kinetic energy of the alpha particle, which is equal to 5 by 4 times of 1.86, which is equal to nearly 2.325. This is equal to 2.325. If you make correction, that is 2.33 to the 2 decimal places. This is kinetic energy of alpha particles, 2.33 MeV. Okay students, see here, the alpha particle is bombarded with nitrogen. Nitrogen is at rest. So we calculate the kinetic energy of minimum kinetic energy of alpha particle. Minimum kinetic energy of alpha particle we calculated here, that is equal to 2.33 MeV. Then it will release the amount of energy minus 1.86 MeV. So that the kinetic energy of alpha particle minimum is 2.33 MeV. Okay. So let us see the next question, and which is related to the capacitors. So the capacitor circuits are given C1, C2, C3 and C4, C5. 5 capacitors are connected in the circuit and 6 volts and 2 volts are given there. And our aim is to calculate the charge across C3. C3 capacitor charge we need to calculate. So the charge Q is equal to, we know charge Q is equal to C3 into V. So charge Q is equal to C into V. So the capacitance across the capacitor C3 is given, that is 4 microcoulombs, and which is multiplied with the potential across the capacitor. Here if you observe, C2, C3, C4 and C5, these 4 capacitors are connected in parallel, which is connected in parallel with 2 volts, right? And these 4 capacitors are connected in parallel, which is in series with C1. So that these 4 capacitors are in parallel means C3 also in parallel with 2 volts. So across C3 the voltage is 2 volts. So 4 into 2, that is 8 microcoulombs. That's it. Okay students, let us see the next problem. A rod of length 2 centimeters makes an angle 2 pi by 3 with the principal axis. This is the rod makes an angle 2 pi by 3 with principal axis. Okay. And next, a thin convex lens, that is, this is the thin convex lens. The lens has focal length is 10 centimeters. So the focal length of lens is given, that is 10 centimeters in the problem, and it is placed at a distance of 40 by 3 centimeters from the object. See the object here, this is convex lens, and from the 40 by 3 centimeters, this is the object, made an angle 2 pi by 3 with principal axis. And the height of image is 30 root 3 by 13. See, this is 30 root 3 by 13 is the height of the image. This is the image. This is the image of the given object, and the height of the image, this is the height of the object, which is given 30 root 3 by 13 centimeters, and the angle made by its principal axis. Actually the height of image made an angle alpha with principal axis, which is given in the problem, and the value of alpha. So if you find the alpha value, which is equal to pi by n radians, then what is the value of n here? So our aim is to calculate what is n, and what is n is, that is alpha value. So if you find alpha value in terms of pi and n, we identify the where the factor n is. So alpha value is our aim to calculate. Next, generally we solve these type of problems many times, because a linear object, if you take in front of a lens, a convex lens like this, then a initial edge and final edge, we take u1 and u2 are the limits of object distance, and we will find the image distance like v1 and v2. So based on that relations, we calculate the length of the image. In the same sense, here the object is given a linear object, but it will make an angle with the principal axis. The difference between the problems what you practice and the here is the the object makes an angle 2 pi by 3 with principal axis. In this case, how we calculate? See, so the linear object, the length of the object actually, you see, suppose the point here, this is A, the point is A, okay, this is the point A and this is the point B. So A is at a distance U1 which is 40 by 3 centimeters, right? And B is at a distance, we need to calculate the distance of B. So to calculate the distance of B, what is the angle here? So here the angle is 2 pi by 3, means the angle here is pi by 3. So pi by 3. And another data is given, rod having length 2 centimeters. So this is 2 centimeters length rod. So if you take the component along the principal axis, this is 2 centimeters. So 2 cos 60. So the length of object is 1 centimeters, a linear length of the object along the principal axis. So A to B, the length is 1 centimeter, we find from the given data. And U1 is 40 by 3. And next U2. U1 is nothing but the distance of the image, the distance of the object from principal, the optic center. And next U2. U2 is nothing but 40 by 3 plus 1, right? U2 is nothing but the position of B from the optic center, which is 40 by 3 plus 1, that is 43 by 3 centimeters. So you know U1 and you know U2. So let us find V1 and V2. So V1 and V2, already we know the relations 1 by F is equal to length relation 1 by V minus 1 by U. So by applying sign conventions, plus 1 by U. Then 1 by V is equal to 1 by F minus 1 by U. Finally V is equal to F into U by U minus F. So this is the relation V Fu by U minus F. So we calculate U1 and U2. In the both cases we calculate V1 and V2. So V1 is equal to F into U by U minus F. F is given 10 centimeters. So 10 into U1. U1 is 40 by 3. So 10 into 40 by 3 by U1 minus F. U1 is 40 by 3 minus F is 10 centimeters. So if you solve it, then that is 40 by 3 minus 10, 30 by 3, 10. Finally that is 40. That is 10 cancel, 30 by 3, that is okay, 10 by 3 cancel, that is 40 centimeters. Okay, and next V2 also we calculated in this way, and V2 is equal to Fu by U minus F. Here F is 10 centimeters and U2 is 43 by 3 by 43 by 3 minus 10. So if you calculate 10 by 3 into 43 by 43 minus 30, 43 minus 30 is, that is 13 by 3. So finally if you cancel 3 and 3, that is 10 into 43 by 13, that is the value of V2. So if you find the length, image length is nothing but V2 means here, that is, this is A dash, this is B dash, let us suppose. So A dash is V1 and B dash is V2. The difference between V1 and V2 gives A dash B dash, that is image length. Okay, so A dash B dash is equal to V1 difference V2, that is 40 minus 430 by 13, right? So that is A dash B dash, that is 630 minus 430 by 13, that is 200 by 13 centimeters. So if you calculate the image length, which is equal to 200 by 13 centimeters. Then calculate alpha value. So because you know A dash B dash, that is image length and image height also. So you know the image length and you know the image height, you should calculate the relation finally. So sorry, here that is 520. So 520 minus 430, 520 minus 430, that is 90 by 13. Okay, and that is image length. So image length we got, that is 90 by 13, and image height is 30 root 3 by 13. Then calculate tan alpha. So tan alpha is equal to, what is tan alpha here? Tan alpha here is equal to image height by image length. Image height already given in the problem, that is 30 root 3 by 13, that is image height, and image length we calculated here, which is 90 by 13. So finally tan alpha is equal to root 3 by 3, that is 1 by root 3. So alpha is equal to 1 by root 3 is nothing but 30. So that is alpha is equal to pi by 6. Okay students, we get alpha is equal to pi by 6. So you should compare with pi by n. Then what is n? 6. That is answer. Okay. So n value is 6. That is the answer. Okay students, generally we solve these type of problems, many problems, but in that case only a linear object is given and which is along the principal axis. But in this case the object is placed at a certain angle with the principal axis. That is the only difference between the problems what you generally do and this. Okay, let us see the next one. Let us see the problem number 5. At a time t is equal to 0, a disc of radius 1 meter starts roll without slipping. See, at a time t is equal to 0, a disc having radius, the radius of the disc is 1 meter. The radius of the disc is 1 meter. See, this is the radius of the disc having 1 meter. Let us suppose the radius is 1 meter. The radius given is 1 meter. Starts roll without slipping. So the disc is rolling and horizontal plane with an angular acceleration alpha is equal to 2 by 3 radians per second square. So it rotates with an angular acceleration. Alpha value is given, that is equal to 2 by 3 radians per second square. A small stone is stuck to the disc. A stone is stuck to the disc. A small stone is attached to the disc. At t is equal to 0, it is at the contact point. So initially the stone is at the contact point here, and after time t is equal to root pi seconds. So while it is rotating the disc at a time t is equal to root pi seconds, the stone detaches from the disc. Actually initially the stone is at this point. So while it is rotating, when the disc is rotating, the stone detached from the disc and flies off. So then the question is, the maximum height measured from the plane is 1 by 2 plus x by 10. Then find x. Then the stone rises to a height, maximum height from the detached point, which is equal to 1 by 2 plus x by 10 from the plane. Then the value of x is. So let us see. Initially, let us imagine, first of all, suppose the stone is fly off from here. So at this position, suppose it is rotating in this way, the stone is fly off from this position. Actually the position here, the contact velocity, which is equal to omega r. V is equal to omega r, which is equal to center of mass, velocity of center of mass. Similarly, along horizontal direction also, translational velocity, which is velocity of center of mass, VCM. So here the velocity of center of mass, the along the tangential direction, that is velocity of center of mass, which is equal to omega r, and translational velocity along the direction of motion of the disk, that is velocity of center of mass, VCM. These two are equal because it is rolling without slipping, that is the condition. So that the resultant of these two velocities, actually the disk is rotating in this way in right direction and which is moving forward, so it is translationally it is moving forward, and the stone is flies off along the tangential direction with the disk and the same velocity. So in between the two velocities there is some angle, and the resultant of these two velocities, let us suppose the resultant of these two velocities is v. So because the disk is rotating in rightwards, and the velocity along the tangential direction is, this is VCM, and the resultant of these two velocities is v. So actually the stone which is stuck is moved along the direction of the resultant velocity, because the disk is moving in forward direction due to the angular acceleration. It moving with pi 2/3 radians per second square is given in the problem. So our aim is to calculate how much height it will rise from the plane. This is the plane, right? From the plane, the stone, how much height will rise, that is the question. So initially we are going to calculate at which angle, at which angular displacement the stone will detached from the disk. Initially we calculate the factor. So we know the relation for angular displacement, theta is equal to omega naught into t plus half alpha t square, because initially it is the omega naught is 0, so that theta is equal to half into alpha. Alpha is 2/3 into t square. How much, after how much time the stone is detached, that is given root pi seconds. So that after root pi seconds the stone is detached from the disk. So theta is equal to root pi by 3. So the theta is the angular root pi by 3, sorry, root pi square, because time square. So the angle is pi by 3. So initially one point we calculated here. So while the disk is rotating in rightward direction, after root pi seconds the stone is detached from the disk, right? So after pi seconds, how much angle the disk is rotated, that's what we calculated right now. That is the first step of the problem, and the angle is here is pi by 3. After pi by 3 angle, the stone is detached from the disk. Next, what is the angular velocity? Here omega. So after time t, what is the angular velocity? Omega is equal to omega naught plus alpha t. So omega is equal to alpha into t, omega naught 0. So that is 2/3 into t is root pi. So that is 2 root pi by 3 radians per second. So that is the angular velocity of the disk after time t is equal to root pi seconds. Okay, that is omega. Next, velocity of center of mass. Velocity of center of mass, VCM. Velocity of center of mass is equal to omega r. Omega is 2 root pi by 3, and radius of the disk is given 1 meter. So into 1, which is equal to 2 root pi by 3. So that is velocity of center of mass is 2 root pi by 3 meter per second. That is velocity of center of mass. So dear students, see, we calculate the velocity of center of mass. So velocity of center of mass is we calculate 2 root pi by 3, and our aim is to calculate the resultant velocity. So if you know the resultant velocity, it is easy to calculate the maximum height, because like oblique projection, it will move like this. Then how much amount of maximum height it will go, it is possible to calculate with help of the factor v. So let us find the factor v. According to the parallelogram law of forces, here parallelogram law of vectors, here velocity vector and one side another velocity vector, velocity is another side, and the angle between these two, here this is pi, this is 90, and this is pi by 3, this is pi by 6, and finally the angle between the two velocities is 120 degrees. So the angle between the two velocity vectors, and that is equal to 120 degrees. So resultant velocity is equal to V is equal to root VCM square plus VCM square plus 2 VCM square into cos 120. So finally, which is equal to VCM. So the resultant velocity is nothing but 2 root pi by 3 as like the velocity of center of mass. So we calculated the resultant velocity 2 root pi by 3. So with that velocity the stone will fly off from where the leaving from the disk. And next our aim is to calculate the directional angle. So because without knowing the projection angle, it is not possible to calculate the maximum height because it is oblique projection. So that our aim is to calculate the angle here. This is the angle. Let us suppose the angle is theta. So the angle is theta here, and next tan theta is equal to, we know directional relation, tan theta is equal to velocity of center of mass sine 120, the angle between the two vectors, by velocity of center of mass plus VCM cos 120. So VCM sine 120 by actually q sine theta by p plus q cos theta. In parallelogram law of vectors we know the same relation we use here. So tan theta is equal to, here the sine 120 means the angle between the two vectors here. And next if you calculate the tan theta value, finally we get that is equal to pi by 3 radians. So if you solve this, theta is equal to pi by 3 radians, because when you substitute v is equal to root 2 root pi by 3, which is nothing but velocity of center of mass, then pi theta is equal to pi by 3 radians. So we get the value of v and then theta. Then apply maximum height u square v square sine square theta by 2g. So substitute v value and substitute theta value, then you calculate the maximum height value is equal to pi by 60 meters. Because we derive v is equal to 2 root pi by 3 and theta is pi by 3 radians. The two values if you substitute in that equation, you get the maximum height. Then what is the maximum height? That is next question. See, so this is velocity of projection, the body projected in this way. This is the plane, and this is the maximum height, right? This is the maximum height. And what we want to calculate, the maximum height measured from the plane. Here the maximum height we measured from the line where the point of the stone which is leaving from the disc, and we are measured the height from here. So from the plane, what is the height? Suppose this is the height. Let us suppose this is height h, the small height is h, like this is h. Okay, because the radius is r and this is h, because this is radius is r, h is equal to r into 1 minus cos 60. Okay, generally a relation which is h is equal to r into 1 minus cos 60. See students, h is the distance from here to here, this distance, and from here to here is the maximum height, already we derived. So the total distance is capital H plus small h, that is capital H is pi by 60 plus small h is r into 1 minus cos 60. R value is 1 into 1 minus cos 60 is 1 by 2, that is 1 by 2. So small h value is 1 by 2. So finally the distance maximum height where the particle goes to the maximum height, that is h, and from the plane the distance is capital H plus small h, which is pi by 60 plus 1 by 2. The value of pi by 60 plus 1 by 2 is given, which is equal to 1 by 2 plus x by 10 in the given problem. So that 1 by 2 cancel. Finally x is equal to pi by 6, that is 3.14 by 6, so that is 0.52. So the answer is 0.52. Okay students, 0.52 is the answer, which is the height from the plane. Okay students, this is the class for today, and we will continue the next class tomorrow. And these questions are given on the previous year JEE advanced questions, and we will continue in the next class the remaining questions. Okay, thank you.